Hi everyone. Here we are showing you guys some examples and good practices to evaluate robustness and the self-consistency of large language models. As we know, large language models they sometimes are sensitive and vulnerable to a small perturbation of input, and whether they can generalize well across different data sets, those we call them robustness. And self-consistency is a kind of a special case of that. It's whether models predict predictions across different inputs imply logically compatible beliefs about the world. I'm going to give you an example here. In this classic NLP task, natural language intelligence task, we have a premise, a runner wearing purple stripes for the finish line, and we have a hypothesis, a runner wants to head for the finish line. So if we change the word runner to racer, which shouldn't change the prediction of the task, the model. However, it shows different prediction results for the natural language intelligence model, which is not wanted. Another case that shows the self-consistency concern is a sparrow a bird? Yes. Does a bird have a feet? Yes. But when you ask the model, does a sparrow have feet? It says no. So that it is not logically consistent with what it says earlier before. And there are some ways to enhance self-consistency and performance of language models. Um, okay, so a lot of people might think, right, large language models achieve impressive performance on benchmarks. And it says like, oh, it's probably comparable to human in this and that task. However, the reality is um, there a lot to be done or needs to be done in NLP to make the large language models robust and reliable. So a very popular technique to help us identify the robustness issue is called adversarial trigger. What it does is um, we attach some trigger to the existing input and to see whether that will influence the prediction. So in this example, we have a fake news detector, and we feed this input to the detector that our vaccine is ineffective, and the model will predict whether this is a fake news or not. So here are a few fake news examples. And if we add a random tag um, and then attach it before it, so here is a blue tire ski bottle tennis, vaccine is ineffective. And the model magically think the whole thing is real news. So that is example to show the some NLP models are not robust enough. And why do we need robust models? This is a very important question because only if we make models robust, we can let the models to focus on the right set of features instead of spurious correlations for predictions. As we show in the previous example, it might use some spurious lexical features to make predictions. And the second, we want to make models do well on out of distribution, what we call OOD domains and tasks. Linguistic styles, style lags, grammatical mistakes, and syntactic structures are all important out of distribution domains. For example, if you train a model on news articles, however, you use it in conversations or social media, that's also out of distribution domain. Another good example is when we train a model on a general corpus, but if you want to apply it in medical domain, that it also will increase the difficulty of the tasks and make models unreliable. Okay, so after we see the importance of robustness and how do we evaluate the performance on tasks and data sets becomes a very important question. Traditionally, we just split the data into training and evaluation and test and assume they have similar distribution and achieve good performance on test set. However, it becomes more and more important to include hard examples in the test set. The held set is not enough. Um, so a simple adversarial attacks are not good proxies for real-world generalization either. In fact, people try to include a wide range of test examples to measure the performance of the model on the test itself instead of on the data itself. They will draw examples, from difficult domains and more difficult, longer sentences, or a slight different dialects to make the task um, measurement more comprehensive. Some good examples are Dynabench and Big Bench. Uh, they are showing people how to evaluate models more comprehensively. Um, okay, so when we look at language models, how do we evaluate robustness in language models? One important thing is the prompt design, right? There's so many ways to summarize articles. You can say TLDR, you can say, please summarize for me. You can say, please give me the main point of the article. So try different prompts and see whether models are sensitive to the different framing of the same task. Another important thing to do is to try zero shot, one shot, few shot learning. Um, it turns out what examples you choose, the order of examples you feed to the models, and what labels of examples you show to the model, to the large language models, are all important to the predictions. And the dominant label of the training usually dominates the predictions. Um, so in this example, if you show a few short examples to large language models, if uh, all the if you show one negative example and one positive examples to make them balance, it will make your results better. However, if in the four-shot example, if you increase the number of positive examples from 0 to 4, you can see the predictions becomes proportionally higher when there are more positive examples. That shows it's important to calibrate the models to let it understand the prior of the label distribution before you use them. And you can check more in this paper, calibrate before use, improving future performance of language models. Last, I want to show the importance of the prompt design. We mentioned let's think step by step is a good prompt to elicit symbolic reasoning in language models. But we didn't mention the original paper actually tried a few different variants of the same think step by step prompt. It says, first, or let's think about this logically, let's solve this by splitting it into steps. Let's be realistic and think step by step. Let's think, and it all produce different performance. And they just empirically show let's think step by step is the best performing one out of these different variants. And it also shows sometimes some prompts lead the model to perform even worse. If you say, don't think, just feel, let's think step by step by reaching incorrect answer. So this is very important when you actually design your prompts and want to make the model express its maximum capability.